From space, the Earth has been called the blue marble. Our planet is dominated by that one blue feature, water. Over two-thirds of the Earth is covered by water. Yet there are vast areas where water is scarce. The American Southwest is one such place where water is a treasured and precious commodity. Big Red, the Colorado River, so historically nicknamed because of its muddy red color, drains over 242,000 square miles of land from Wyoming, Colorado, Utah, New Mexico, Arizona, Nevada, and California. On a map, Big Red appears to be just a thin blue line, but it is the aquatic lifeline for this arid part of the country. Historically, the flows of the Colorado River were unpredictable, driven by the previous winter's snowfall. The region was first surveyed in a daring 1869 expedition led by Major John Wesley Powell, who described Glen Canyon this way: "We have a curious ensemble of wonderful features, carved walls, royal arches, glens, alcoves, gulches, mounds, and monuments. From which of these features shall we select a name? We decide to call it Glen Canyon." In the Old West, water law was based on the simple rule that whoever first used the water had the first claim to that water. They used the phrase, "first in time, first in right." Because of the scarcity of water in the Southwest, the basin states constantly fought over the waters of the Colorado River. In an effort to resolve their differences, the states in 1921 formed the Colorado River Commission, chaired by then Secretary of Commerce and future President Herbert Hoover, and after much negotiation came to an agreement about sharing the Colorado's water. The Colorado River Compact of 1922 recognized that the Colorado River drainage provides much of the water supply for the southwestern states. The states agreed to divide the waters of the river between the upper and lower basins. To ensure that water makes it each year to the lower basin, the upper basin is obligated to deliver a minimum of 75 million acre-feet of water in any 10-year period to the lower basin. The measuring point for these deliveries is located 16 miles downstream of Glen Canyon Dam at Lee Ferry. 75 million acre-feet is a lot of water when you consider that 1 acre-foot is about 326,000 gallons, or roughly the amount of water an average family of 4 uses in 1 year. In addition, a 1944 treaty with the Republic of Mexico guaranteed an additional 1.5 million acre-feet to Mexico each year. In order for the upper basin states to regulate the delivery of water to the lower basin states, while still utilizing their share of the river, especially during times of drought, a dam was needed. Glen Canyon Dam was planned during the post-World War II era, when the United States was undertaking great civil works projects like the interstate highway system, airports, and large dams. Bureau of Reclamation engineers and geologists surveyed Glen Canyon looking for a site. A suitable dam location had to meet 3 key criteria. The area forming the basin could contain an immense amount of water. The canyon walls and bedrock foundation were strong and stable enough to safely support the high dam, and the dam must be economically feasible to construct. Glen Canyon provided an excellent and secure foundation for a large dam. There were no significant geological concerns, no earthquake faults, and there was uniform rock, which made designing the dam much easier. But there was a logistical problem to overcome. This perfect site was quite possibly the most remote spot in the United States. The nearest town was 70 miles away. There were no roads, no railroads, and no way across the river. In April of 1956, Congress authorized the Colorado River Storage Project, and final planning for construction was completed. 6 months later, President Dwight D. Eisenhower from Washington, D.C., pressed a telegraph key on October 15, 1956, to set off explosions at Glen Canyon, and the construction of Glen Canyon Dam was officially underway. The building of the dam involved several phases. First, a bridge across the canyon had to be constructed. The river had to be diverted and excavated down to bedrock, the dam built, the hydroelectric generators placed, and finally, the reservoir filled. When the project began, the Glen Canyon site was virtually inaccessible, and construction crews were forced to drive 200 miles to cross from one side of Glen Canyon to the other. A bridge had to be built to allow trucks to deliver material and equipment across the canyon. First, however, a footbridge was constructed to allow workers to cross the canyon. It consisted of a 6-foot wide chain link fence suspended on cables with chicken wire sides and a 700-foot drop to the canyon floor. As construction began, men called high scalers worked suspended on ropes above the rushing river, preparing the canyon walls for the dam. They had to remove all overhangs and loose rock for the safety of the workers below. As you tour the Glen Canyon Dam, imagine yourself in their place. These men, held only by a single rope, did some of the most difficult handwork possible. They stepped over the edge of the canyon and did their day's work, where every minute was dangerous. Others worked around the clock as welders, concrete layers, track layers, heavy equipment operators, and excavators. Working nearly 24 hours a day, the steelwork for the bridge was finished on August 6, 1958, almost 3 months to the day after construction began. The completed bridge, which is 1,028 feet long and rises 700 feet above the river, was finished in January 1959. At that time, it was the world's highest steel arch bridge. The 200-mile trip across the river was now reduced to less than a quarter of a mile. Diversion tunnels were needed to channel the river flow diverted by cofferdams around the dam site during construction. 2 3,000-foot-long tunnels were dug on each side of the canyon. These tunnels, 45 feet in diameter and lined with 3 feet of concrete, moved the Colorado River around the construction site. The excavated material from the tunnels was used to make the cofferdams. Through this process, workers de-watered the bottom of the river so that construction of the base of the dam could begin. On February 11, 1959, the cofferdam was finished and the right diversion tunnel was opened, and the Colorado River was diverted around the construction site. Crews immediately went to work, excavating down 137 feet to the ancient Glen Canyon bedrock for a solid foundation. Secretary of the Interior Fred A. Seaton had the honor of placing the first bucket of concrete on June 17, 1960. At that moment, after nearly 3.5 years of preparation work, Glen Canyon Dam began rising out of the riverbed. A concrete mixing plant was constructed, and an aerial tramway was strung across the canyon so the fresh concrete could be delivered quickly to the correct spot. The concrete was placed in a series of blocks, some as large as 60 feet wide and 210 feet long. Individual blocks rose 7.5 feet at a time as concrete was placed into forms of that height. Because concrete produces heat through a chemical reaction as it sets up, it has to be cooled. Thousands of miles of pipes were buried in the concrete. Chilled water was then pumped through the pipes to cool the concrete. In addition, ice water was used in the process of mixing concrete in an effort to cool the structure. With the amount of concrete in the Glen Canyon Dam, it would have taken hundreds of years for the dam to cool down without such cooling processes. Each bucket held 24 tons of dam concrete, and it took over 400,000 buckets to build the dam. Delivered by the tramway, concrete was placed night and day. Over 5 million tons of concrete make up the dam and power plant. That's equal to enough to build a 4-lane highway stretching from Phoenix, Arizona to Chicago, Illinois. With thousands of men on the job, workers and their families set up camp in tents, trailers, bunkhouses, and whatever else they could use. Quickly, the new government town of Page, Arizona took shape, named after John C. Page, Commissioner of Reclamation from 1937 to 1943. Page sprouted businesses, schools, and churches. During the peak construction years, its population swelled to over 7,500. Today, nearly 9,000 people make their year-round home in Page, and even more flock to the area in the summer months to work, fish, and enjoy Lake Powell. The massive dam continued to take shape, and by March 1963, the right and left diversion tunnels were closed. At that moment, Lake Powell was born as the dam began storing water. Construction would not be completed, however, until September 13, 1963, when the last bucket of concrete was placed in the dam. Chief Project Construction Engineer Lem Wiley marked the moment by tossing his favorite hat into the mix. The dam was dedicated by Lady Bird Johnson, the nation's First Lady, on September 22, 1966. It is believed that Mrs. Johnson was the first woman to dedicate a large dam.
My hat is off to the men who figured the stresses and strains and who diverted the river during construction, and to all the rest of the dreamers and doers who brought this project live born into its rocky cradle. Glen Canyon is not just a Colorado dam, it belongs to the nation. The hardcore water and power benefits of this dam are well known. Its bonus is the heavenly blue lake that begins here and winds its way through Navajo country toward the labyrinth of the New Canyonlands National Park.
A new era for the Glen Canyon area was beginning. The dam was storing water, but much work was still ahead. The hydroelectric power plant equipment had to be installed. One of the primary functions of the dam is to provide hydroelectrical power to people in surrounding states. Energy is generated by the force of falling water through huge pipes in the dams called penstocks, turning turbines that drive giant electrical generators. The first hydroelectric power was produced on September 4, 1964.
Unit 1 is ready to roll and will be up to speed in approximately 30 seconds.
By 1966, all 8 generators at the dam were working at full capacity, providing 5 billion kilowatt hours per year to over 1.7 million people in Arizona, Colorado, Utah, Wyoming, New Mexico, and Nevada. The plant has the capacity to produce more than 1.3 million kilowatts of electricity, with each of the 40-ton steel shafts turning at 150 revolutions per minute, generating nearly 200,000 horsepower. With all 8 generators operating at full output, over 15 million gallons of water pass through the power plant's penstocks each minute. The electricity is upgraded by transformers from 13,800 volts to 230,000 and 345,000 volts for transmission to distant markets. It took 17 years for Lake Powell to completely fill for the first time. Due to the area's unique geography, it's a lake like no other. Approximately 186 miles long, Lake Powell boasts over 1,960 miles of shoreline, a distance equal to the entire west coast of the United States. Filled to capacity, Lake Powell holds over 26 million acre-feet of water. To put that in perspective, that's enough water to flood the state of Tennessee under 1 foot of water. In 1983, Lake Powell was filled to capacity, and record spring runoffs caused the Glen Canyon Dam to open its spillways. After 3 weeks, the water coming out of the spillways wasn't clear, but muddy. The spillways were closed and inspected. Crews discovered holes in the 3-foot-thick walls of the diversion tunnels were being created by the cavitational forces of the rushing water. One of the holes was 40 by 50 feet and over 30 feet deep. This cavitation damage forced engineers to reevaluate the original design of the spillways. New state-of-the-art design technology was used, with air slots installed to diffuse and disperse the cavitational forces that had caused the damage. Subsequent tests verified that the modification had solved the problem, and the spillways were ready to be used again if needed. Safety at all Bureau of Reclamation dams is of paramount importance. Glen Canyon Dam is constantly monitored by workers and sophisticated instrumentation to ensure the dam is safe and that no potential for danger exists. All who had a hand in shaping Glen Canyon Dam, from the geologists and designers to the laborers and contractors to the succeeding generations of reclamation employees, are committed to maintaining a safe dam. Glen Canyon Dam towers 710 feet above the bedrock and 583 feet above the riverbed. It is the fourth tallest dam in the United States and the second tallest Bureau of Reclamation dam. At its crest, the dam is 1,500 feet long. At its base, it is over 350 feet wide. Reclamation's tallest dam is Hoover Dam, which forms Lake Mead and is 16 feet taller. Standing tall, Glen Canyon Dam serves the 7 basin states of the Colorado River by ensuring a reliable supply of water in wet and dry years alike. The mighty Colorado River is as essential to a great 7-state area in the West as the Great Lakes are to the industrial heartland of America. The turbines of Glen Canyon Dam's power plant have electrified cities and farms, playgrounds and factories, while Lake Powell has become a world-renowned mecca for those in search of a unique recreational experience. As the early years of the 21st century dawn, Glen Canyon Dam continues to serve, now with a newly refined eye towards stewardship of downstream resources in Grand Canyon. As long as there are people in the southwestern United States, there will always be a need for the water stored behind Glen Canyon Dam. The legacy of the coming years will be in the adaptive management philosophies at Glen Canyon Dam that will ensure the downstream ecological resources are protected while meeting water delivery obligations for generations to come.